Factor analysis is a bit like regression analysis in the sense that it builds on the idea of correlations, but it's typically used to group variables based on the correlations among them. That's often done in situations where the number of variables is just so large that they're unwieldy to work with individually. And in that situation, it's called dimension reduction. So, for example, suppose that as visitors are waiting to leave Kiwi Land, we give them a survey to ask how they enjoyed their stay. But as part of that, we also ask them a series of other questions about leisure time activities and how much those different leisure activities appeal to them. That might be helpful in informing our advertising strategy or identifying potential sponsors. Suppose that we ask about 20 different leisure activities. If we wanted to look at the correlation between individual pairs of those activities, we'd have to check 190 different combinations. So, for instance, do people who like going on multi day hikes or tramps also enjoy gardening? Is there a correlation between your liking of gardening and your liking of biking, and so on? Furthermore, besides looking at how people respond to the individual activities, we might want to look for differences between groups. So, for example, do younger people like different things than older people? Do men like different things than women? Do local New Zealanders like some different things than international visitors, and so on? If we wanted to look for those types of differences by five brackets, two gender categories, and six countries of origin, we need to examine 1,200 statistics, and that's just too many. Of course, we could try grouping these leisure activities into categories using judgment, so let's give that a try and see what happens. The goal is to take these 20 activities and to put them into categories by deciding which things you think are correlated with one another. So you get to choose how many categories there should be and which activities go into each category.